there's no if-then logic here at all. We are simply adding up each shape's area, and we're not asking each shape for its height, its width, or its side length, or whatever by some third-party calculating code. Instead, we just are delegating to that shape and say, calculate your area, let me know what it is. If we run this, we will also see that it's not working. So by applying the refactoring such that we take rectangle and square and break them apart so that square no longer is a rectangle since they are not substitutable for one another, and then moving that behavior into shape such that we can access it polymorphically on each object itself, we're able to get a design that now follows the Liskov substitution principle and also is going to follow the open close principle, because we'll be able to add additional shapes and add them to this collection and not have to touch this code that calculates the area of multiple shapes. So why should you take the time to look for and fix Liskov substitution principle violations? If you notice obvious smells like the one I just showed, either where you're doing if-then checks within a polymorphic enumeration of a collection of types, or where you're inheriting from a type or an interface and not fully implementing it. In either one of those cases, you may want to consider fixing that violation by using a better interface, or simply fully implementing it, or refactoring your code such that a different base class is used that does in fact offer substitutability. Otherwise, you can use the same rules as for the open-close principle, which is that if you find yourself having to change the code more than once or two times, then it's time to refactor it such that it satisfies the open-close principle and also, therefore, the Liskov substitution principle. A couple of last tips. Remember, tell, don't ask. You should prefer not to interrogate objects about their internal state. Rather, if you find yourself doing that, it's a good idea usually to move that behavior into the object in question, or possibly extract out an object that has the state and the behavior collected together. Rather than asking, let me know this property, let me know that property, let me know the other property because I want to do some operation on them, you should just tell the object, run this operation, and it should use its own internal state to do so. You should also consider refactoring to a new base class when you have two types that seem related, but you are not able to substitute them one for another, as we saw with the square and the rectangle. In that case, you can create a third class that does, in fact, allow each of them to be substituted and move both of the base classes such that they derive from this new base class. To summarize, conformance to the Liskov substitution principle allows you to properly use polymorphism in your application and will produce more maintainable code. You should remember that is substitutable for is the preferred relationship that you should be looking at when you consider inheritance, rather than simply the is-a relationship that's so commonly used. Some of the related principles to the Liskov substitution principle include polymorphism and inheritance, of course, as well as two other solid principles, the interface segregation principle and the open-close principle. For more reading on this subject, I recommend the Agile Principles, Patterns, and Practices in C# book by Robert C. Martin and Micah Martin, which you can get at the URL shown on your screen. And I need to offer some credits for the image of the ducks that I showed. And I need to thank you for your time, and I hope that you return back to Pluralsight On Demand to learn more about software fundamentals in the near future. Thank you very much. Hi, this is Steve Smith, and in this Pluralsight On Demand module, we're going to look at one of the fundamentals of software development, which is the interface segregation principle. The interface segregation principle represents the letter I in the SOLID acronym of Principles of Object-Oriented Design, and applying it can help you create projects and applications that have fewer hidden dependencies and are more cohesive and easier to maintain. In this module, we'll begin by defining the interface segregation principle and see why it's a problem when it isn't followed. We'll look at some examples of classes that have too many dependencies because the interface segregation principle was not followed, and these classes were forced to depend on fat interfaces. Once we analyze the example and find what the problems are, we'll refactor it in order to apply the interface segregation principle and result in a better, more maintainable design. Finally, we'll look at some tips for when and how to apply the ISP principle, and finally some related fundamentals and wrap up. So the interface segregation principle basically states that clients should not be forced to depend on methods that they do not use. This comes from the excellent book Agile Principles, Patterns, and Practices in C#. The corollary to this, of course, is that you should prefer small, cohesive interfaces to fat interfaces. I really like these motivational posters. You can actually put them up in your team room if you like, or in your cubicle. This one is the interface segregation principle, of course, and says, you want me to plug this in where? The idea here is that we have a very small dependency that we require, which is this left USB cable here. But instead of being able to simply plug that into a USB port on a computer, let's say, instead we're being forced to haul around this large dependency represented by whatever this widget here is, that has knobs and switches and buttons, as well as multiple USB ports. And it's basically way more than we need. It does provide us with a USB port that we can plug into, but it also requires a whole lot more stuff that we don't actually care about. So when we talked about the interfaces that we're supposedly segregating with the interface segregation principle, it's important for us to further define what we mean by an interface. Of course, in C#, an interface is a reserved word and represents a non-implementable type that specifies a public set of methods and properties that must be implemented by anything that chooses to implement that interface. However, it's also the public interface of a class. So any class, any type, whatever its public interface is, whatever its public methods and properties are, if these are things that are used by some client and it only requires the use of some small subset of those things, it's possible that you would end up with a better design if you were to segregate that class in some way that made it so the client didn't need to use as much of it. An example of this would be the classic design pattern, the facade pattern, which basically lets you take a large class or a set of complex classes and replace them with a much simpler class that offers only the subset or interface that the client actually needs. Let's go ahead and look at an example showing how violating the interface segregation principle results in a worse design. Let's take a look at a real example first. This is the ASP.NET membership provider that ships with ASP.NET 2.0. So the base type here is membership provider, which is defined in system.web.security.membership-provider. And this is what's used out of the box for things like the SQL membership provider that many websites are built on today, and allow you to leverage the login control and forgot password control and other things out of the box with ASP.NET 2.0 or later. One of the common criticisms of the membership provider, though, is that it has a very fat interface. In fact, it has quite a large interface. If we look at this very simple implementation of the membership provider, where we have not yet implemented anything at all, you can see that just to fill out this set of not implemented exceptions for each method or property is over 100 lines of code. Now, if you look at some of the classes that utilize this interface, this membership provider type, we can consider the login control from, again, the ASP.NET world. And here we have the system.web.ui.login control, and specifically we want to look at this method here. So we have a method that's aptly named authenticate using membership provider, and this calls a little utility called loginutil.getProvider, which fetches the current membership provider. And that method is shown here. You can see it's not doing anything too special, it's just grabbing whatever the currently configured provider might be. And then the part that we're interested in is right here. Once it's gotten a membership provider, this type here that's returned by the static method, the method that it calls is validate user. Now, if we look at all the rest of this class, we'll find that this is in fact the only reference to the membership provider that the login control has, which makes sense because obviously the login control is a very cohesive control. It's very tightly focused. It has a single responsibility pretty much of validating the user. And so it would make sense that it would only need to call this one method, and that it would only need to be concerned with passing that method the two things that it requires, which are, of course, the username and the password. But if we want to leverage the login control in our ASP.NET website, and we want to do so with our own custom membership provider that talks to something other than SQL, or we have our own version of the SQL membership provider, or we talk to Oracle, or we talk to Facebook, or whatever, we're going to have to implement the membership provider interface, because the login control depends on membership provider and not on, for example, an iValue user interface that would be specific to what it actually needs. Now, moving away from this example of ASP.NET membership, because it would be rather time-consuming to actually work with this large interface, we're going to work with another example that's still very practical. In many of my applications, I use a configuration section in order to define some of the common settings. I think most developers in .NET do this as well. If we look at a very simple implementation called About Page, that you can imagine might exist in the ASP.NET application with some modification, of course, you can see that it's taking in a text writer, and then it's going to basically write out the current application name and who wrote it, the author name. Now, it's not going to hard code these things. It's going to do this in such a way that it's reusable and configurable. And so it's going to use this configuration settings class in order to achieve this. Now, of course, this application does a lot of things. So this configuration settings class has grown somewhat large over the course of time of building this application. Let's have a look at that class. So the configuration settings class inherits from configuration section, which means that we can use it to read from the web config or app config file of our application. It has some boilerplate code in here whereby it exposes a static settings property, which is of its own type. And when called, we'll go ahead and give you a loaded up version of this setting. We also take advantage of some nice features with attributes here, where we can specify that some of these configuration settings are required, and these will actually be enforced at runtime when someone attempts to retrieve one of these properties. The actual implementation of all this is beyond the scope of a talk on the interface segregation principle, but if you are using .NET, it's worth learning how this stuff works with the configuration property. So if we look at a summary of these types, we'll see that we've got an application name, an author name, a cache duration, database server name, database username, database password, and a web service-based URI. These are all the things that represent my settings for my application. The way this has been implemented also is using a configuration file. So you can see that I've defined my new section here called configuration settings. And then I have all those settings specified here with the default configuration. Now with this in place, everything actually works. I can go into my About Page tester called About Page Should, and I can say About Page should display the application name. And if I run this, we should get a green light, and we do. So what this is basically saying is that I expect to get interface segregation by Steve Smith as my output when I call aboutpage.render, and I don't pass it in anything. So we have a default constructor, but we have a node here that says this is hard to test. We have to have an app config in order to test this. If I go and I take my app config and I remove it, or I change the name of anything in here, so I change my name to Steve Smith 2, and then I want to rerun my tests, we find that this is going to be very brittle. Because now we're going to see that it failed. Steve Smith was expected, but we actually got Steve Smith 2. So the problem with this is that when you start relying on these configuration files throughout your code, two things happen. One, you've got a dependency on a file, which means your unit tests are much more brittle and more difficult for multiple different users to have working correctly on their own machines. And the other issue is that now we've got a bunch of stuff that we had to set even though we didn't need it. So, for instance, in order to do all this testing of the About page, I had to go into app config, and I had to also put in settings for cache duration, database server name, all this other stuff that I really don't care about at all for this test or for that class. But if I go look at configuration settings, I'm going to find that those things are all required. So if I didn't set them, I would be getting an exception at the time when I went test it. And we can show that real quick as well if we just delete one of these. And then change my name back to Steve Smith. Run our test one more time. You can see that now we're getting another error that says that we threw an exception, and if we look at that exception, we'll see that it's telling us that the required attribute cache duration was not found. So again, because of our dependency on this fat interface of configuration settings, we are now getting hosed by these dependencies of things that we really don't care about. Let's go analyze what some of the problems are with this. So the problem is that we have a client class like the login control that needs simply the validate user method of the membership provider, but unfortunately it's being forced to use this massive membership provider API, this fat interface that has one thing it needs and 30 things that it doesn't need. Likewise, we have an About page example that simply needs an application name and an author name, but it's being forced to deal with this configuration settings class that has additional properties and things that are required to be set on it, but which again, our client, the About page class, really doesn't care about. Furthermore, we're having to deal with configuration files in a class that really just cares about two strings. So it's bringing on these dependencies that we really don't want to have on our simple little class. So interface segregation violations result in classes that depend on things they don't need, which increases coupling and reduces flexibility and maintainability. Let's go ahead and look at how we can refactor our design to make it conform with the interface segregation principle and take care of some of these problems. The first thing we can do, if we go ahead and move into another folder here called Configuration 2, is we'll extract out the dependency on the settings file into something that we can inject with our test. So what this would let us do is specify an interface called iConfiguration settings, and then push in that interface through what's called dependency injection and the strategy pattern, which we'll learn about more in the dependency inversion principle talk. Otherwise, our class, if it doesn't have anything passed in, will default to using configuration settings.settings property that it was actually using before. So with this refactoring, we've gone from our initial setup that had an About page that simply was hard-coded to use this static property called configuration settings to now one that goes and uses an interface that gets set to a field, this private read-only underscore configuration settings, and then that is a class that's used in the render method. So where's this interface? Well, we created this interface by looking at all the things that our configuration settings class needed. And I added some comments here that kind of shows what I consider to be the general gist of each of these settings. So we have some application identity settings, some performance tuning settings, data access settings, and web service API settings. Now all of these things are in one interface because we have the same configuration settings class that we had before, but we are going to make it so it inherits from the iConfiguration settings interface. Now, truth be told, I was doing this before because I've only got one of these classes in my solution, but it wasn't important until we got to this refactoring step. If we look at our test code now, in configuration 2, we've got About page should still, and you'll see that if we call About page now, which is in configuration 2, it should still work. And this is the exact same type we had before, but we're also now able to create our own implementation of configuration settings and basically create a fake version of our configuration here. And I've done that and I've set it to be a test app name and a test author name as my two values that I care about. And then I also still had to implement this other huge interface with all these other things that I don't care about. And I've done what most people do, which is I take that ugly stuff that I don't want anyone to see and I sweep it under the rug using the region tag. Anytime you see people doing things in a region tag that they don't want you to see or that they're clearing up the class, usually that's a smell and it's telling you that these are things that need to be somewhere else, need to be refactored, need to be gotten rid of. So the next thing that we can do once we've got this class is we can take the settings class and pass that into our about page. And now we can actually write tests that don't rely on a configuration file. We can show that this particular value right here for test author name and test app name is actually what we have when we run this test. And so if we run the tests that are in this class, we'll see that they go to pass, showing that the original implementation of running from the config file still works. And now we're also able to run this test with our own implementation through the use of the interface that's being injected into our about page class. So this is all very nice and it's getting us a little bit further away from our dependency on the configuration file. It hasn't really done anything for us in terms of segregating our interface. We took our big fat interface that was configuration settings, and that class's interface consisted of all of these public values here. And we simply moved that from a class interface to an actual C# interface that still had the exact same signature. So we made a little bit of progress, but we didn't really get to the point where we're conforming with the interface segregation principle. So the next step is to go and look at our about page and say what are, in configuration 3, the next step is to look at about page and say what are the actual things that we depend on. And so we've realized, especially after looking at comments on our configuration settings about what exactly these things are, we realized that we only care about application identity settings on this page. And so we can create our own interface called application identity settings, and we'll define it right here. And it only includes the application name and the author name. Now, once we make this change, we have an about page that works fine for any new implementation, but if someone is still passing in the old configuration settings class, this is going to break because configuration settings doesn't know anything about application identity settings. And furthermore, if we break the configuration settings and make it so that it no longer has these two properties on its main interface, but only has them on this sub-interface, that's going to cause some of the things to break. So in order to make this work, we're going to have to make some changes to our base interface. And so if I do that right now, all of this will work, and I can get rid of my to-do fix comments. So if we undo this stuff right now, we'll see that this doesn't work, because I'm passing in configuration settings, but I'm expecting our application identity settings. So in order to make that work, I can simply delete this stuff here from my main interface. And I can go and say, well, actually, this interface inherits from application identity settings, which, oh, by the way, I need to go and implement that other interface. But once I do that, everything magically works again, because this interface and the other are now the same as they were before. I'm able to rely on just that subset of the interface that I care about, and everyone else is still able to use the exact same interface they used before. So through this simple refactoring, I'm able to apply the interface segregation principle and get myself away from having to depend on that interface without breaking anything else that's dependent on the existing interface. If we look at our test, we'll see there's a little bit more that we have to do here, basically in terms of uncommenting stuff. So this wouldn't have worked before, but now I can uncomment it, and it should work. You can see I've got test settings like I had before, but there's no longer any region with stuff that is not being implemented. I'm only using the interface that I actually need. And I can run my tests now with just this small interface and see that it works. So if we run these tests, we see that they pass. So some of the smells that you should be looking for in your code that indicate you might be violating the interface segregation principle include unimplemented interface methods. Whether it's an abstract class or any kind of base class or an actual interface, if you find in your code things where you're overriding methods from your base class or your base interface and then simply throwing a new non-implemented exception or doing some other kind of degenerate implementation, you should realize this is probably violating ISP, because clearly the class that's using this implementation is not using this particular method, and therefore it's using a smaller subset of the actual interface that it's being forced to depend upon. Remember too that these violate the Liskov substitution principle, because now these degenerate classes will not be substitutable for their base classes when clients expect for all of these interfaces, the entire interface to be implemented and all the methods to do something useful. Another smell is one of a client that references a class, but it only uses a small portion of it. This is very similar to the last smell, but not quite exactly the same. This is more from the client side rather than from the implementation side. When you see this, sometimes you can make a facade or some other kind of class that your class depends on, and it makes it so that you're not depending upon the larger class, which is perhaps more likely to change and break your class. When should we fix violations of the interface segregation principle? Like most of these principles, you really only want to address them if there's pain. If there's no pain, then there's not really a problem that needs to be attended to, and you should continue adding new features and fixing bugs and generally adding value to your application. However, if you find yourself depending on that interface that you own, and this is causing problems because of the dependencies involved, the best thing to do is to create a smaller interface that has just what the client needs, have that interface implement this new interface as we just did with our demo, and then reference the new interface within your client code, ignoring that interface now. If you find fat interfaces are problematic, but you don't own them, for instance, if you have the example I showed with the membership provider that's built into the .NET framework, something that you can do is create a smaller interface with just what you need, and then implement this interface using an adapter that implements the full interface. So this would allow you to basically work with a subset of the large interface, and the adapter would be between you and the third-party interface that you don't have control over. So some basic tips for the interface segregation principle: keep your interfaces small, cohesive, and focused. Whenever possible, you want to let the client define the interface, because this will ensure that the interface really only includes what the client needs. And also, whenever possible, package the interface with the client. Ultimately, you can package the interface in a third assembly that both the client and implementation depend upon, and only as a last resort should you try and package up interfaces with their implementation. So to summarize, the interface segregation principle states that you should not force client code to depend on things that it doesn't need. You want to make sure you keep your interfaces lean and focused. Refactor large interfaces so they inherit from smaller interfaces that your client uses. There are some related fundamentals here, including polymorphism, inheritance, the Liskov substitution principle, and the facade pattern. I recommend the Agile Principles, Patterns, and Practices book that I mentioned earlier. You can get it at the URL shown here. And I have to provide some credits for the motivational poster that I showed earlier. There's a set of them available at this URL that you can download. They have some high-res versions, so you can print them out for free and put them up if you like. And with that, thank you very much. This has been a presentation of Pluralsight On Demand by Steve Smith on the interface segregation principle. I hope you'll come back again soon to learn some more about software development. Hi, this is Steve Smith, and in this Pluralsight On Demand module, we're going to look at one of the fundamentals of software. Hi, this is Steve.